today we're discussing trigonometric integrals. So I put one on the board that we can start with, but let me before that just kind of give you an idea. Well, what are we trying to do? And these are going to be integrals. They're combinations typically of sine and cosine, or tangent and secant, or cotangent and cosecant. Though we won't see that many of those because it's the same as tangent and secant. But if I look at an integral like this, sine to the fifth dx, you know what you want to do. You want to do a u substitution. It would be great if we could make u be sine x, then I'd have u to the fifth. But my problem is I don't have a du, right? If I wanted to do this with u substitution, I'd also need to substitute in something for the dx. I need to substitute in for my du. I don't have it. But what we can do, though, is we can use trig identities to get it. So that's the idea of these trig integrals that we're going to do. Use some trig identities to transform the integral into something that we can use u substitution for. So it is like a two-step process. In the end, it's u substitution, but you have to figure out how to get there. Okay? So primarily, we are going to use, for sine and cosine, we're going to use the Pythagorean identity, and we'll also use some half-angle identities later on. But for the first two examples, all I need is Pythagorean identity, meaning sine squared x plus cosine squared x equals 1. Now notice this. This sine has, it's an odd power, right? It's 5. So I can think about this as sine to the fourth x times my extra one, my extra sine x dx. And the reason I did that is because my Pythagorean identity is good for things that have squares or fourths or whatever. It's good for even powers. Okay? Once I see that, I can substitute in here and make all those cosines. Why? Because the derivative of cosine is negative sine. The idea is that this guy is going to now become my du. So if sine x is my du, then u has to be cosine. And I want to change all my sines to cosines except for one, which is going to be used for my du. So that's the strategy. It's not just that we're going to make sine du, because that didn't work for sine u. That didn't work out, right? We were stuck. But by moving it around a little bit, using some identities, we can transform it into something where we can still make a u substitution, and then we can solve the problem. All right, so let's see how we do that. So I need to substitute in here and make all these cosines. Okay, so I'm just going to write here before I do that, I'm going to do, in the end, my u substitution is going to be u equal cosine x, right? I'm just not sure how much it's going to be on the board here. So du is minus sine x dx. So that's where I'm heading for. Here. Sorry, I'll move it over a little so it shows up. All right, there we go. Yay. All right, so using this, I can write sine squared x is 1 minus cosine squared x, right? And sine to the fourth is sine squared squared. So going back to my integral, I can put this in 1 minus cosine squared x quantity squared, right? Because that's sine to the fourth. And then my sine x dx, he's just going to come along for the ride. Now I have to do a little bit of work. I have to work out what this is. It's going to be 1 minus 2 cosine squared x plus cosine to the fourth x. And then I have this as sine x dx. Okay? So now can make my u substitution. Oh, wait, technically I could have made my u substitution here, right? Whatever. I did it this way. It's fine. So I'm going to make my u substitution. That's going to give me 1 minus 2u squared plus u to the 4th du with a minus sign. Why with a minus sign? Because the derivative of cosine is negative sign, so I can't keep that negative in there. So I just threw it out front. Well, you could pull it in through. It doesn't matter. Right? Now this is an easy integral to do. Keep my negative. It's going to be u plus 2/3 u cubed plus minus, sorry you guys, plus u to the 5 over 5, right? So, plus c, because it's an indefinite interval. In the end, of course, I need my answer in terms of my original variable x. So my last step is to substitute in what x is. I'm going to write it in 2 lines. So it's going to be minus cosine x plus 2/3 cosine cubed x minus cosine to the 5th x over 5 plus c, and that's my answer. Sorry, the board is, oh, there we got it. Okay. So that's my answer. It's a little bit more long, right, than our usual, but that's fine. That's what's going to happen, because when you use these trig identities, it gets long. It's not hard once you get the u substitution properly, right? This integral was easy to do, but you have to figure out how to substitute right. So let me do another one. Where's my sheet here? Okay, here we go. Cosine cubed x sine squared x dx. All right, so here we only have one option, right? We do have cosines and sines, but we only have one option in considering, I can't talk today, considering what our substitution is going to be, because I have odd power of cosines and an even power of sines. So if I break off one sine to be my du, I'll have another single sine, which doesn't help me because, right, my Pythagorean identity uses sine squared and cosine squared. It doesn't tell me anything about sine just by itself, right? I can't do anything with sine by itself. So here's my problem. So that's my problem. But I do have a cosine cube. So what I can do is I can pull off one of those. I'm just going to write it again. Cosine squared, sine squared, and then cosine x dx. So my plan is going to be, I use the odd power, one extra, put it over there. This is going to be my du. Okay? So if du is cosine, then u is going to have to be sine, right? So it's going to be u equals sine x. Du is cosine x dx. Right? That's going to be what I'm looking for. I have some sines. I've got some cosines. The sines just are fine, but now I want to change my cosines to sines so that I can use this u substitution. So cosine squared is going to be 1 minus sine squared, and then I have sine squared x, and then cosine x dx. And so I can move this out the way I did, or I can just right now As soon as I have everything signed, I can make that u substitution. It's the same. This is going to be less writing, right? 1 minus u squared du, right? Here is my du. I kept it on purpose. Okay? So this is now an easy integral. U squared minus u to the 4th du. So I have 1/3 u cubed minus 1/5 u to the 5 plus c. And then I just put in that u is sine, and I'm done. No, plus, minus. There we go. Ha! At least I noticed. Okay, so, right. Pretty much that's how it is. Whenever you have a even power, you can do that. Now you'll notice here I only had one choice because, whenever you have an odd power. I had an odd power here and I had an even power here. So I had only one choice for my du, which was cosine. If it had been cosine cubed, sine cubed, I could have chosen either cosine or sine to be my du, which means my u could have been sine or cosine. I would have ended up with answers that look different, right? Depending on if it was one where I could have made that choice, my answer would have been in either sines or cosines. It would have looked a little different. These, I'm doing them as indefinite integrals, so there's always a plus c. It turns out with these, that plus c is key. Those two things, the expression with the sines and the expression with the cosines, are the same up to a constant. So you shouldn't worry about that, okay? If you have a situation where you can choose either substitution, it's really up to you. If it's a definite integral, it won't matter because regardless of which one, it will turn out to be the right number. Now, in the next video, we are going to do some where there's no odd powers and there's only even powers. So that one you can't pull off the du the way we've done.